Okay, so when reviewing trig, especially exact values, we got to start with the basics. 30, 60, 90. That would be a 1 square root of 3 2 triangle. 45, 40 would be 1 1 root 2 triangle. Now you definitely can replace these hypotenuses with a 1 to make it a true unit circle. I'll talk about that again in a minute, but I'm going to leave it just how it is for right now, just to kind of go back to the very beginning. Then we've got Sohcahtoa, okay? Sine is opposite over hypotenuse, cosine is adjacent over hypotenuse, and tangent's opposite over adjacent. Want to keep in mind that neither opposite or adjacent can ever be the hypotenuse, okay? So when thinking about something like what is sine of 60 degrees, okay, what we're looking at here is sine. That would be opposite over hypotenuse, so opposite would be root 3, and the hypotenuse would be 2. And that's how you do basically all of the trig values. It does get a little bit more complicated, and we're going to explore that next. Okay, so we're going to explore these and do some more examples here, but in calculus, we're pretty much never going to use 60 degrees. We're pretty much always going to use pi over 3. By pretty much, I mean definitely. So 30 degrees then would be pi over 6, and both of the 45 degrees would be pi over 4. In fact, anytime you want to convert, you're just going to multiply by pi over 180. All right? This is something, though, you're not going to want to do the conversion. You're going to actually just know these, okay? So, in fact, all of the 60-degree reference angles are going to be something over 3. All of the 30-degree reference angles is going to be something over 6, and all the 45-degree reference angles are going to be pi, something pi over 4. Okay, right here we actually have the unit circle starting with 0 and then going to 30 degrees, 45 degrees, 60 degrees. Over here we have 90 degrees, and so on all the way back to 360. These are radians, and we're pretty much always going to use radians, and again, pretty much means we're always going to use radians. So what we're going to see instead are things like cosine of, say, 4 pi over 3. Okay, so I haven't talked about other quadrants yet. I'm going to review that here in a minute. But the first thing you got to know is what is the reference angle. So if it's over 3, remember I said that's always going to be a 60-degree reference angle. So you can come back over here to your 30, 60, 90 triangle and say cosine, which is adjacent over hypotenuse of 60. So what's adjacent to 60? That would be 1. The hypotenuse would be 2, so 1/2. Now, if you remember back from pre-cal, there could be a negative in front of this. Okay, and so I want you to think, is there not? Do you remember how to do that? And it has to do with the quadrants, okay? And so what I'm going to do is I'm going to draw my axes a lot darker, and I'm going to put a big A, S, T, C. All students take calculus, or there's various things. And what this means is, this is how you know what things are positive and where. Say 4 pi over 3. Okay, that's over here in the T quadrant. That means tangent's the positive one. That means cosine is negative. Okay, so now we can see this is really explained here in this chart right there. Any of this, copy down in your notes, pause, rewind, whatever you need to do. Okay, so A in the first quadrant means everything is positive. Everything, everything. Second quadrant, only sine and its reciprocal cosecant. We haven't talked about reciprocals yet. We will in a minute. Tangent and its reciprocal, they're the only ones that are positive. And again, when I say the only ones that are positive, that means everything else is negative. Okay? And here you can kind of see the whole opposite and adjacent and the x and the y values. I'm not going to get into that in this video. If you want to hear that, you can go back and watch one of my old pre-cal videos on YouTube. But this kind of helps you know what's positive and negative. So just to kind of test it out, let's do tangent 11 pi over 6. So the first thing you got to do is say, okay, what's the reference angle? That's 30 degrees. All right, so we got to think, what's tangent of 30? If you need to go back and look at that special right triangle, you can. If you just need to redraw it, you can always do that as well. 30, 60, and this is what you can do on your own anytime. This is why trig exact values should never be difficult. You can always recreate it. So tangent, toa, is opposite. So we want to go opposite of the 30. That's a 1. And we want to go the adjacent. That's a √3. And so you can leave it like this, or you can, you know, simplify the radical, which is probably what you did last year. Either one of these, they're both okay. And in calculus, you don't really need to do simplify. I don't care which way you have it. And the only other thing you need to decide is positive or negative. Okay, so what quadrant is 11 pi over 6 in? Well, I can see clearly here it's in quadrant 4, which means only cosines, positive and negative. So my answer is, again, we can write it either way. A couple things to note would be, okay, well, what do you do? How do you know? In other words, without looking at the unit circle, how do I know that 11 pi over 6 is in the 4th quadrant? So I'm going to let you in on a little secret. All of these are always improper fraction, meaning 11/6. 11's the bigger number. So what you can do instead is rewrite it as 1, and like if I did the division, what would be left over? 5, right? 1 and 5/6 pi's. And think of pi as a halfway around the circle, because that's where pi is. So 1 and 5/6. So that means that you've gone 1 pi, and is 5/6 going to be less than a half or more than a half? Hey, if you're in calculus, you should know whether 5/6 is less or more than a half. 5/6 is definitely more than a half. That means you're definitely in the 4th quadrant, okay? And so just kind of another example would be, let's say we were doing, let's say, I'm going to make this really interesting. 21 pi over 4. Okay, improper fraction. The first thing you want to do is you want to break it down into be a mixed number. So 4 goes into 21 how many times? 5 times, right? And then there's just a 4th left over. So what we're going to do is we're going to go around the circle 5 1/4 pi times. Okay, so let me erase this so we can have it clear. All right, so what we're going to do is there's 1 pi, 2 pi, 3 pi, 4 pi, 5 pi, all right? And now we've got a 4th. So a 4th of a pi. Remember, a pi is half the circle. So is a 4th of that less than a half of a half, basically? Or are we going to go all the way over? We're not, right? We're going to stay right here. Okay, and that actually puts us right there at 5 pi over 4. Those would be what we would call coterminal angles. Okay, so depending on what we were doing, this is how we'd know, okay, only tangent and cotangent would be positive in that quadrant, the others would be negative. Okay, if you are like, I don't get this, ask me a question in class about that, because this is very helpful, I think. Okay, so just to recap, we've got our basic Sohcahtoa there. We already looked over that. I've talked a little bit about reciprocal, and you probably do remember these. Cosecant is the reciprocal, meaning you switch the H and the O. From opposite over hypotenuse, we want to switch it to hypotenuse over opposite. All right, and the way I remember that is the S and the C go together. So it's not that two S's go together, it's that, so cosine, it couldn't be cosec, it has to be secant. And then tangent and cotangent, everybody seems to remember this. Okay, so this is just a review. Again, if you have questions over this, ask me. I'm not going to go much more into this. But let's just do one more practice. Let's say we had secant, and I'm going to do 11 pi over 6. Okay, so first of all, we got to think, okay, this is the reciprocal of cosine. I mean, this is how you do this all from scratch. Okay, ultimately, you really kind of want to memorize these. But if you don't have it memorized, this is what you want to do. You want to say, okay, whatever I get for cosine, I'm going to switch it. All right? Over 6, that's a 30-degree reference angle. Write it down as much as you need to. 30, 61. You should get really good at writing these triangles if you do it this way. Okay, so for cosine, I would actually do adjacent over hypotenuse. So for the 30, the adjacent is root 3, and then the hypotenuse is 2. But remember, I want to switch it. So I want to do 2 over root 3. Now the only other thing you need to do, and this is where the 11 comes into play, is what quadrant is this in? Okay, and so again, I'm going to go ahead and just kind of do my little cheat over here, and I'm going to think 11, 6, that's 1 and 5, 6. We had this one earlier. 1 pi, 5, 6 pi would be more than a half of that. So that puts us right here where cosine is actually positive. So I'm going to keep this positive. Now, this little radical sign may be bothering you in calculus. It doesn't bother me, so don't let it bother you. Totally fine. Definitely you can simplify it, but you don't need to. Okay, the only thing I have not addressed are the quadrantal angles. These are the angles that are on the axis, okay? And so I'm going to go ahead and use degrees here, and then we are quickly going to say, okay, well, what are these supposed to be in radians? Because remember what I said, we're going to be dealing with radians in calculus. So this would be pi over 2 up here, and then this would be 3 pi over 2. And another way of thinking about this is 1.5 pi. Again, this makes sense. You go 1 pi and then you go 1/2 pi. Okay, so again, I'm going to do that over here as well. Pi over 2, pi, and 3 pi over 2. And if you think 360 is missing, that's because 360 would be right here, which would of course be 2 pi. Okay, I went ahead and put the chart right here. And when I taught pre-cal, I used this thing called the OIO chart, okay? You don't have to use this, however you learned it's cool. I'm going to go over this OIO chart right now. So once you get up your 4 quadrantal angles on the side and then your sine, cosine, and tangent, this is how it goes. OIO, meaning like, oh, I owe you some money, right? I just remembered that. OIO. And then the next line goes, I owe you. Like I owe you money. And then I remember, hey, I actually paid you back. And so then I go, oh, I don't. Like I don't is -1. I don't owe. And then you go, I don't owe you. Okay, it's stupid, it's cheesy, but I'm telling you, since the mid-90s, I have been doing this way. So it's worked for me. It may or may not work for you. You can always kind of look at it on a trig as well. So if you wanted, or on the unit circle. So if you were trying to do like say cosine of pi, okay, if you know this chart, you could say easily -1. Got it, good, okay? And if you do this enough, you kind of memorize them. But so I can think, okay, well right here I have no triangle. In other words, it's like normally I would have a triangle like this, but this top part has gone all the way so that it's completely flat. All right, and so you got to think cosine, which was adjacent over hypotenuse. When I'm looking at my reference angle right here, when I go back in blue, reference angle, what your adjacent, okay, would be 1, we'll just say, and your hypotenuse would be the exact same, so 1. So whether your adjacent and your hypotenuse are 2 over 2 or 1 over 1, that becomes 1. And the whole negative thing is that we're over here in these quadrants. All students take calculus, so definitely we're over here, both of these, cosine's negative. Okay, so that's again how you can get negative. It depends on what type of student you are. Use what works for you and go with it. That was your quick trig review. I am going to have another video where I show a hand trick that is kind of like real cutesy. If you thought this was cutesy, it's like way cutesier than OIO. And some of you are going to like it and some of you are going to hate it, and so you may or may not even want to watch that second video.